day, grade 11s. Welcome to another video. This is Miss B's Hive, and I am Miss B, your physical science teacher. And I hope you like this video. Comment down below if you have any difficulties or if you'd like to add something. And don't forget to subscribe. So for this video, we will be discussing dative covalent bonding or coordinate covalent bonding. That's another name for this particular type of chemical bond. So first up, I want you guys to read through what is a dative covalent bond. So in physical science, definitions are very important. So we need to make sure we understand exactly what is expected of us. So a dative covalent bond or coordinate bond is a bond where there is one pair of shared electrons between two atoms. Now, this might still be a bit airy-fairy and far-fetched for you, so let's try to bring it down. Now, dative covalent bonding occurs where there is a sharing of two electrons which both belong to the same atom. Right. So when I say the same atom, both electrons that are shared are from one particular atom. So the other element that is sharing with that has what we call a vacant. So a condition here is there must be a vacant orbital. And right, so it has to have a vacant orbital. Now, you should have been taught that in a particular orbital, there are two electrons. So, in this particular bond, there must be no electrons in one element or one atom. All right. So, there are two common examples which I'm going to show you how they are done or how this bond came to be. So it is the hydronium and the ammonium ion. So it's very easy for you to understand or remember what we're talking about. Okay, so first of all, I said the NH3 and also water can undergo dative covalent bonding. So these two are the most common examples for your grade level, right? Grade 10 and grade 11. So let's see. Okay, so I'm going to draw the Lewis dot structure for NH3. Now, nitrogen is in group 15 and has 5 valence electrons that look like this. Now we have to place them according to Hans law one at a time, and then we pair. All right. Now there are 3 hydrogens, so I'm going to use my X's to put my hydrogens in. Right, now there is this here, which is called a lone pair. So, lone pair, the nitrogen atom has 2 electrons which make up a lone pair. Now, lone pair means that the electrons are not shared with another atom. Right, now these ones that I'm circling in yellow, these are bonding, so these are called bonding pairs. So if I were to determine in this ammonia compound, so if I were to look at it, there is one lone pair and there are 3 bonding pairs in this. So this is the basis of where a dative covalent bond forms from. All right, so let's just see. Now I'm going to erase this so I can write for you. Obviously, a bonding pair are electrons that are a pair of electrons that are shared between atoms, and a lone pair is an electron pair that has not been shared with another atom. All right, so we're going to see how a dative covalent bond forms. So I first have my NH3, or in other words, I have this compound forming. I'm just going to draw the Lewis dot shape because that'll make you understand nicer how this type of bond forms. So those are my hydrogens. Now, in order for this type of bond to form, it needs to react or come into contact with an H plus ion. So this is an ion of hydrogen. And as you can see, this plus means that the one electron that the hydrogen did have, it lost. So essentially, this hydrogen has a vacant orbital, no electrons whatsoever in its orbital. So they then share electrons. So my nitrogen that I had in this ammonia ion is essentially going to take these two electrons and use both or share both with this hydrogen to form an ammonium ion. So we put a square bracket around it and a plus sign. So that shows us now that the ammonia compound, this, shared its lone pair of electrons with the hydrogen to form an ammonium ion. So I'll just write the name there so that you can see that I now have an ammonium ion. And it's indicated by using a square bracket and this plus sign to show that it gained this hydrogen, or rather is sharing this hydrogen with its lone pairs, or borrowing its lone pairs to this hydrogen over here. Okay, so to write that very neatly, we will have H plus this NH3 to form and I think I'll just make this in green so that you can see that that hydrogen is over there. So that is how a dative covalent bond forms, and it forms the ammonium ion. Now, one such other compound that can form a dative covalent bond is water, because the water molecule, if I were to draw it, it contains oxygen, which is in group 16, which means it has 6 valence electrons, 1, 2, 3, 4, 5, 6 around it. And then we know that there are 2 H's because the formula is H2O. Now, these are lone pairs, right? Do you see them? They are these that I've circled in yellow. Those are my lone pairs. And my lone pairs are able to borrow these electrons to a hydrogen atom to form a hydronium ion. So let's draw that out neatly. So I have my H plus. Remember, I said in the previous example that this is a vacant orbital. Now, just before we move on my water molecule, if I were to look at how many lone pairs and how many bonding pairs it has, we are going to just go back and see that water has 2 lone pairs. And lone, you think of the word alone, meaning not bonding. And it also has 2 bonding pairs. Right. And water has this bent shape, but I'll do that in another video. For now, let's go back. So we have an H plus H2O. And let's just make our H again in green. Right? To show us, we put the square bracket around it because that shows us that it has formed I forgot to put the plus sign over there. It has formed an ion. So I'll have my O with its electrons around it, 6 of them. There's my H's. Now the green hydrogen will come over here, and now I have H3O plus. If I count how many hydrogens, I have 1, 2, 3 H3 and 1 oxygen. So now the hydronium ion has 1 lone pair and 3 bonding pairs. Right, 3 bonding pairs. Alright, so that's how dative covalent bonds form. I really do hope that you enjoyed this video and you learned something, and I hope to see you back on another one. Bye. Don't forget to like, comment, and subscribe. Till next time. Peace.